this session. All right, let's go ahead and get started. Thank you everyone so much for joining us today for this Education Transformation 2020 presentation, How to Run a Self-Reflection Classroom. My name is Kayla Elkin, and I'm on the marketing team here at Hawks Learning. Our speaker today is Professor Kevin Shryock. Professor Kevin Shryock is an instructor of mathematics, an instructor of manufacturing, and a math education researcher. He is also a career changer with a bachelor's degree in industrial engineering and years of industry experience, during which he gained insight into how mathematics is used in a variety of applications and professions. Today, he works to advance the field of math education. We are so excited that Professor Shryock is here to share his experience and insight with us today. If you have any questions throughout the webinar, please enter those into the Q&A as we go, and we will answer them live after Professor Shryock's presentation. On that note, I will hand it over to our presenter. The floor is yours, Professor Shryock.
All right, thank you. Welcome, everybody. Thank you for attending. I also want to extend a big thank you to Hawks Learning for hosting. And at the end of the presentation, as was mentioned, there'll be an opportunity for questions from any of you in attendance. So please post any questions you have in the Q&A as we proceed, and I'll address them at the end of the presentation. Today, I want to share with you my recent research and my thesis on the effect of self-reflection on relative student success, which I conducted at Northern Illinois University as part of my master's program. Now, this study specifically assessed the effect of self-reflection exercises on student success in Calculus 1. But more specifically, it sought to assess a plug-and-play classroom framework which could replace performance grades at any level of mathematics. Calculus 1 was simply chosen because it has one of the lowest pass rates of any math class. Also, it's a class that is shared between both colleges and high schools. Thus, if this framework was successful at the calculus level, it may be more likely to succeed at other levels and at other schools as well. In addition, this framework can be applied to synchronous and asynchronous classes, whether they are in person or they're virtual. It's also completely free. The framework itself centers around a holistic rubric. That is to say, it's a single rubric that was applied to all homework, quizzes, and tests equally. And it corresponded with self-reflection worksheets, which you can view after this presentation in detail on the recording page for this session via Hawks' website. We'll also post a link at the end of the presentation. So students were told that they would be graded only on whether or not they accurately reflected on their own work, not on whether they were correct on the assignments. The goal was to develop students' awareness to both their conceptual understanding and their presented work. Now, the results were quite impressive. Those participating in the framework outperformed those who declined to participate. The participants also outperformed two sections of Calculus 1 that acted as control groups. Compared to all other groups, those participating also had significantly higher pass rates, greater confidence, and a greater satisfaction in their class experience. Now, this presentation begins with an introduction to the related theory and the research. I then discuss the design of the study and the research questions that directed my data analysis. I'll then conclude with the results of the study, and then I attempt to interpret those for you using the context behind the scenes. So a little bit about me as the teacher researcher. I do have an undergraduate degree in industrial engineering and a master's degree in mathematics with a focus in math education. At the time of conducting this experiment, though, I had only taught for one semester previously at Calculus 3 level, and I was concurrently performing this experiment while teaching an Introduction to Manufacturing course at my local community college. I have since that time taught multiple sections of Calculus 1 using this framework. Now, I do have 5 years of experience in a variety of industries, and I often bring this experience into my classroom as an example of math in the workplace. And I've also worked as a research assistant for a study introducing K-12 teachers to similar examples of math outside of the classroom. And I share all this with you for two reasons. First, it will provide insight to my classroom culture. In manufacturing, I was taught not to accept a failure and to develop great product. And I carry this value into my teaching. I believe in pursuing a 100% success rate for my students against high standards, and I work to develop simple classroom procedures that other teachers can easily implement. And you will see this inspiration throughout this study's design. So let's begin with the introduction. Robert White was the president of the National Academy of Engineering in 1968, and he stated that it was time to turn calculus from a filter to a pump. However, a study conducted in 2010 and published in 2015 by the Mathematical Association of America, or MAA, says that we seem to have made little progress towards this vision. This survey involved 300,000 Calc 1 students from colleges and universities across the country, and what they found in the classroom will be all too familiar to us teachers. A vast disconnect between students and teachers, a large variety of student abilities and experiences, and teachers struggling. This resulting in student demoralization, regardless of whether they pass the class or fail the class. Now, the most immediate question that I had when seeing these shocking survey results was, is this demoralization because math is just an inherently demoralizing subject? It doesn't appear so. Pew Research suggests that out of the 58% of US adults who enjoyed math classes during grades K through 12, most of them point to the subject matter as the main reason they liked the math class, rather than the way that the math classes were taught. So what is the harm of such widespread demoralization? Well, it's not simply limited to the students. Failure to meet the insatiable public demand for STEM talent ultimately affects job growth. The US's math education has been identified as shockingly below that of many of the world's leading industrialized nations, according to Career Profile in 2019. High-level mathematics courses are required for degrees that correspond with 46 of the top 50 salary jobs in America. What this means is that a failure to pass math class can be directly tied to limited national growth and lost opportunities for students who wish to affect their socioeconomical status. Not to mention, this issue has been compounded by coronavirus. As of June 5th, the New York Times reports an estimate that the average student could begin the next school year having lost as much as half of their expected progress in math. Now is the time when innovative teaching practices are desperately needed, else we may be sacrificing our nation's future. So I began my research by analyzing these sources of demoralization, and I started with the first being the widespread student-teacher disconnect. Now, there is a void between the demand and the supply for higher levels of math education, both from a professional and an academic standpoint. Students are flooding the school system's computer science and engineering programs. Enrollment for these programs has nearly doubled in recent years. Bioscience, even more impressive, has nearly tripled its enrollment. And what's more is that this demand does not seem to be slowing down. Sadly, budget cuts have prevented post-secondary education from meeting this demand with additional teachers. What's worse is that in these overcrowded classrooms and lecture halls, students are often met with poor teaching practices. The Mathematical Association of America stated, for example, that only 1/3 of Calc 1 faculty report that they often or very often require students to explain their thinking on assignments. Instead, teachers perform a robotic charade called lecture-based or direct instruction, in which they copy well-organized procedures in real time in front of students. Students then copy the same procedures into their notebook, mimicking a practice that gained popularity hundreds of years ago when it was easier to copy textbooks by hand rather than to print them. The irony is that the students already have these textbooks, and in fact, they're usually using the exact same textbook that the teacher originally copied their solutions from. This creates an echo chamber in which students are discouraged from nonlinear thinking and pressured to perform with as few mistakes as possible in the exact way that they were shown. Now, this, of course, is a foolish means of engaging students who know quite well that when professionals want recurrent procedures to be followed, they rely on machines and personal computers, not on paper and pencil. As a coping mechanism for this miscommunication and misrepresentation, students develop performance goals rather than learning goals. And you can hear it in their language when they say, I just need to get through this test, or C's get degrees. Again, their focus is not on learning, but on performing, on getting through math class as if it was a gauntlet. But what mathematicians universally understand is that there is a difference between computing and thinking mathematically. Mathematics is and was discovered by zigging and zagging, not by wandering a straight and narrow path. Learning comes from making mistakes, recognizing these mistakes, and applying corrections. Yet our students are deprived of this genuine experience and thus are deprived of true mathematics learning. And the number one culprit is performance grades. The second source of student demoralization is a teacher's inability to effectively manage the wide variety of students in the classroom. Again, undergraduate Calc 1 acts as just an effective microcosm of this, but it's easily found at every level, every grade, and every subject. But sticking with Calc 1 just for this research, let's start with analyzing the various inputs from which students can enter the class. These can be from a low score in AP Calc that does not receive college credit, a high score in AP Calc that a college chooses not to credit, college pre-calculus, high school pre-calculus, and retaking college calculus because of a failing grade. Now, at the one end of the spectrum, the higher end of performance, Patterson and Ewing reported in 2013 that when matched by ability, students participating in AP Calc significantly outperform their college classmates. But on the other end, pre-calculus has been found to have significantly lower success rates. In fact, sometimes pre-calculus students do better when they skip their recommended remediation altogether and go straight to Calc instead of starting at pre-calc. Now, if you add to this mix that pre-calculus students are learning not only how to balance their harder material, but also the college environment, and then consider students who are retaking, who are fighting off feelings of inadequacy, and who often don't feel that they need to pay attention to the easier material, even though the easier material was likely the problem that eventually compounded to prevent them from passing the course in the first place, we can see that there's a lot for teachers to balance. But let's also not ignore the non-mathematical factors. Students are dealing with a burden of transitioning to a different school. They are learning how to relate to students with vastly different study skills. They are discovering how to engage in classrooms of strangers. And then add to this the complexity of virtual or asynchronous courses, and we can see how it is easy for teachers to become overwhelmed by the student variety and thus resort back to standard teaching practices. Therefore, if any ambitious teaching practice, specifically the self-reflection framework that I wanted to look at, is going to be successful, it has to allow for students with vastly different abilities to easily relate to each other, the teacher, and the material. Now, we can see that it's no wonder students are getting demoralized. Sadly, our attempts thus far to reform math, and specifically Calc 1, have had mixed results. Oftentimes, these reform efforts report either greater performance or understanding, but then they often leave students with feelings of discontentment or vice versa. Calculus reform courses such as inquiry-based learning, for example, report students have greater discontent for a period of 2 years, which is crazy when you think that they would still need to be enrolled in math classes for those 2 years for that to be resolved. Technology is often something that teachers grapple onto to improve, but when you look at the effects of using graphing calculators in digital activities, they average no impact unless you look at it when graduate students use it, and then it actually averages a negative impact, so there's no luck there. Group work, word problems, flipped readings, and student explanations of thinkings have all been tried as reforms, and they do show a small impact into education, but they have a small negative impact on student attitudes, confidence, enjoyment, and the desire to take more classes on the subject. So now we can really clearly see the problem. Teachers are balancing a disconnect with their students. They are having difficulty relating to students with a growing variety of circumstances and abilities, and our current reform efforts are coming up short. So what hope is there for a math teacher or an English teacher, a science teacher, and a student who crave an improved classroom experience? Thankfully, we do have some insight in which key factors may be critical to improving our classroom success. That is, at least for grades K through 12, which have received the bulk of the math education researchers' attention. Now, John Hattie, who's shown here, is a researcher who compiled 1,400 meta-analyses composed of over 80,000 studies involving 300 million K through 12 students. And he has compiled over 250 influences and organized them by how effective they were at promoting learning, with a cutoff at 0.4 as being the above average improvement indicator. Now, above this line of demarcation, we can see that there are plenty of different factors. Student self-reported grading, for example, student efficacy, or the belief that they can affect their own learning. Also above this line is priorability and teacher clarity. Now, below this line, Hattie placed factors such as homework, which flies in the face of traditional believing that additional worksheets and practice problems are all that is required for students to learn. There are even factors below this line that have a reported negative effect, such as performance goals, whereas learning goals actually have a very high effect size. Now, Hattie's work inspired me a need to develop classrooms that capture these positive effects and lessen students' focus on their performance. So I set out with the goal of developing a plug-and-play classroom framework in which I could duplicate Hattie's findings and improve student satisfaction. And I called this my self-reflection framework. To study this framework, I gave my students a choice to participate in this activity or not. If they chose to participate in the framework at the beginning of the semester, they could opt out at any time if it didn't suit their fancy. But they could only opt in immediately following a test day, so that I could accurately determine whether their participation in the framework was what affected their next test's scores. Now, the framework itself is quite simple. Students were responsible for completing assignments and then reflecting on them. And in exchange, they would receive credit based only on their completion and their reflection, not their performance. If they attempted the assignment and the reflection process in earnest, then they received a score of 100%. Performance grades were only given on tests and midterms, which accounted for 75% of their final grade. So let's discuss this design in a little bit more detail. The cornerstone of the study was its rubric. The rubric was given to all of my students in the experimental class as part of their syllabus at the beginning of the semester. Now, this rubric was unique to my section, and no other sections received this rubric. The rubric itself was modified from one that was developed by Grays Lake North High School in Grays Lake, Illinois. It was used so prevalently there, in fact, that the rubric is provided in every guided note packet and that the students are given, and posters referencing this rubric are hung on the walls of each math class. Now, let's sample just one section as an example. It's structured in such a way that the students can score themselves easily in the left column depending on the point value of the question. A heading is on the rubric that stresses the level of mastery and a brief description of what that mastery level means. So here, for example, Mastery Plus is identified by a complete understanding and a use of the mathematical operations. There were also multiple examples of how this could be demonstrated, from correct calculations to clear and organized work. Now, these categories include developing mastery, understanding, incomplete understanding, and no evidence of understanding. But the common theme throughout this rubric is clear communication of understanding. Understanding is what is being stressed. Now, specifically in the study, to make sure that the teacher feedback wasn't a confounding variable, a decision was made to provide highlighting feedback to students rather than written feedback. And the highlighting feedback drew students' attention to where their mistakes occurred, but it did not provide insight into what the mistake was. The goal here was to prevent students from simply matching teacher feedback passively to the rubric. Instead, students had to actively work to decipher why their work was highlighted and deserving of additional reflection. So, two examples. The first one here, a student, you can see, attempted to communicate, for all you math people out there, that the limit could be computed by directly substituting for x, but they forgot to remove some notation, and that communicated a gap in understanding. So what I did is teacher was I highlighted the entire line to show that there was something here that was a concept that they had missed, rather than just simply saying, please correct this notation. In the next example, you can see that the student actually just simply misreads a table that was presented above this problem. And so I highlight just the numbers to say that that might be something deserving of reflection, but the written language here was perfectly fine, and so it's left not highlighted. Now, let's discuss how the students would actually use the rubric and this highlighted feedback to perform their reflections. Instead of asking students to complete written reflections, I decided that students would simply fill out a grid with check marks. And this kept the burden of reflecting and reviewing these reflections from becoming overwhelming. It also avoided any risk of inequity for students whose English language skills may still be developing. Students could review their highlighted, consult the rubric, and place markings in the corresponding worksheet and then score their work off to the side. Here you can see that a student scored themselves in the mastery category for question 1, indicating that they had made a small mistake and weren't deserving of Mastery Plus. Yet they still decided that the mistake was not large enough to warrant docking their point value. Now, these types of decisions were common that students had to make, who had to continuously ask themselves whether they believed their work was reflective of a typo or a larger gap in understanding. Students could total their scores at the bottom of the worksheet so as to keep better track of their performance. But this was, again, just simply for reflection. Remember that these points did not affect their actual grades. This was all just an exercise to build awareness as to what their grades would have been. Students performed this reflection exercise on every homework, quiz, test, and midterm throughout the semester. However, on tests and midterms, which were the only scores based on performance, I would pre-grade students' tests on a separate sheet and then deliver this to students following and independent of their self-reflection exercises. Now, this framework sparked many questions, such as whether or not this option would be attractive to students. If so, which students might be attracted to it? Would there be an effect on performance similar to what Hattie had found? Would this affect a student's interest in mathematics? Would students feel that the self-reflection option was to be credited for their improved awareness and their understanding? Would students get better at reflecting throughout the semester? And lastly, what would be the effect on students ultimately passing the class? So let's move on to question 1. Would students choose to participate in this framework? Out of the 24 students that were enrolled in the section, 15 students opted into the self-reflection option at the beginning of the course, and 9 opted out, showing that there was a clear majority of those who preferred to be in rather than out. This indicated that the option was initially attractive. 13 students stayed in this option the entire semester, as shown by the dark red here, and 1 student chose to opt in following the first test, as shown in the lighter red. This again created a majority, indicating that the framework remained attractive as students participated within it. Only 2 students who initially opted into the self-reflection option chose to opt out. Actually, 1 chose to voluntarily. They were slightly confused about the design when they originally signed up for it, and then another student was removed because they were not regularly completing the reflection exercises. Now, due to the small sample size, this isn't enough for us to say with statistical certainty that we are certain this would be attractive for a majority of students overall, but I can say from personal experience, I've now used this framework for 2 semesters, and I can say that it is often cited by students as their favorite part of the course. If they are simply if they give this framework the opportunity to impress them, it very often does. Now, question 2, there's a bit of an eye chart, don't get discouraged from it. Which students would choose to participate? Might they be more or less mathematically adept, or would there be any distinguishing factors between those who chose in or out? To determine this, I compared the test scores by reflection option. And the black bars here are the students who chose the self-reflection option, whereas the red bars are those who did not, and you can see that it goes through the 4 tests of the semester. But what I want to draw your attention to is the difference between the curves of these 4 those who chose in and those who chose out. See how the black and the red bars follow different curves in test one in the midterm. You can see that the red curve, for example, here kind of dips, and we have a lot of people performing at the high and a lot of people performing at the low, whereas the group of students who opted in follow kind of more of a central trend here. And again, we can see different trends in the midterm. There's a different organization to the bars over here between the black and the red. But if you take a look down at test 3, you can see that they start to become much more similar, and by the final exam or test 4, they're practically identical. Turns out that this is because students who performed low on the no reflection group end up dropping the course right after the midterm. So essentially this group right here. It seems that the students who opt out of the reflection group dropped out of the course for 2 reasons, or they chose not to participate in the self-reflection for 2 reasons. Either they were already high performers and they think that the self-reflection exercises weren't necessary for them, again, this group right here, or they are not the high performers and they just simply don't want to do the extra work that would be required to reflect. That's this group right here. Now we can see that by the midterm, how the self-reflection students have all shifted towards the higher scores. You can see that there's, again, this trend where there are more towards the high. But those who are in the, or excuse me, here we are in the midterm, those black bars have shifted to the left or the higher scores, but there is not much of a change in these red bars. So following the midterm, when this group drops off, we see that the true story is that all of those in the self-reflection option are actually performing, as well as the highest performers of those who chose not to participate at all, and that trend continues all the way to the end of the semester. So our answer to our question, simply put, is that students who are willing to reflect and improve are attracted to the self-reflection classroom. But students who opt out for a more traditional classroom are more likely to either stagnate or fail out by the time the material grows in difficulty. Now, to confirm this result, I looked at student test performance over time, using only the midterm and the final scores, since these exams particularly were graded by a panel of instructors, not just me, and this panel of instructors had no reference to my rubric, so this was a completely independent jury, if you will. Now, there's a clear difference in grade trend between the experimental classroom. What you will see is that all of the slopes are negative, which is to be expected, because the final exam was cumulative and it was twice the length of the midterm, so meaning it's just an objectively harder test. However, the no reflection group dropped in performance much more than the self-reflection group, and the self-reflection group dropped less than the control groups. In fact, this difference was so severe that it actually resulted in statistical significance. And just as we saw before, those participating in the self-reflection option eventually perform at the same level as the most adept students who opted out of the self-reflection option. But now we can see that they also overcome the point of struggle after the midterm, when concepts become more critical to success than mechanics. We've slowed the decline in their grades. So performance improvement was significant. What about the framework's effect on math interest? Here we can see that student responses to the question, do I have an increased interest in math, given at the end of the semester? The red bars are shifted to the right, indicating yes, much more than either the MAA's national averages or the black bars that represent the no reflection group. Statistically, we were 1% away from drawing statistical significance, which is pretty impressive given that this is a very small sample size. So overall, very favorable results. What about understanding abilities? Students were also asked again to rank their agreement on a scale from 1 to 5 with the prompt, the self-reflection option has helped me better understand my abilities. And the average agreement was statistically significant at every single time we surveyed throughout the semester. What's more is that the distribution shows a general trend towards the positive over time. And so what this means is that students feel they have a better and better understanding the more self-reflection that they do. An almost identical story can be concluded with regards to the question, the self-reflection option has resulted in me better understanding the material. The average was significantly higher than the simple agreement with the trend towards the positive over time again. In fact, not one student reported any disagreement with either this prompt or the prompt before. So question 7 was whether or not students improved in their abilities as to reflect over time. Could they get better at this effort? Specifically, might they have eventually been trusted to self-grade entirely? In short, no. They did become more adept at recognizing their own errors. However, there was always a gap in what the errors the teacher could recognize versus those that the students could recognize. Now, this should be obvious, but it brings up an important point. There is a lot of confusion between self-reflection and self-grading, and in my study, I have found that it is important to keep them separated. Grading is for the teacher, reflection is for the student. Our 8th question might have been the most important, and that is the effect on student success. Here you can see a comparison of the number of students who successfully passed the course with a C or better, represented in light gray, versus those who withdrew, failed, or dropped, represented by black. There was a clear and a statistically significant higher number of non-reflection students who did not pass the class as compared to those in the reflection group. So in summary, did we accomplish our goal in developing a simple plug-and-play classroom framework that has the potential to work with a variety of students at a variety of levels? Yes. Yes, 100 times yes. We showed that this framework has the potential to significantly improve student performance and may result in greater interest in math. It is an attractive option for a majority of students. It correlates with lower drop rates and higher completion rates. On top of that, students credit the framework itself for their feelings of success. So if we recall Hattie's findings back from the beginning, where did we fall? Right on target. Higher than the effect size of prior ability, teacher clarity, homework, performance grades, and learning goals. And so to what do we credit this elevated effect size? The self-efficacy, which came from practicing self-grading. So what do these findings mean in context? Well, in context of teaching theory, it means that grades do not serve the role we think they do. Ample grades are not a means of ensuring student success, but a demoralizing distraction that prevents students from relaxing and learning. In terms of teaching practice, this shows that the MAA's findings need not be the case. Student-teacher disconnect was properly bridged with this framework, and a variety of students were successfully managed. On top of that, students left with higher interest than when they arrived. These results become even more significant when one considers that when I was conducting this experiment, it was my first semester teaching Calc 1 and my second semester teaching at any level. These results are a likely trivial comparison to what teachers like you with greater knowledge and experience might accomplish with the aid of such a self-reflection framework. Also, I believe this framework may have multiple applications in subjects outside of math, such as physical sciences and even language arts. Given that it's based on a clear rubric and an environment open to making mistakes, this could prove revolutionary to classes in a variety of contexts. Now, this does bring me to a couple specific recommendations for virtual teaching. Like most, halfway through last semester, I was forced to convert my classroom into an online format. In order to lessen the confusion on my students and provide them all with the same benefits that I'd seen through this study the previous semester, I decided that all of the students were going to be mandatory. It was going to be mandatory that all students in my class join this self-reflection option. And now, some of them had been doing this already by the time that the quarantine hit, and for some of them, for these, there was no change. For the rest, the result was quite incredible. I had students complete their work in their notebooks and they could easily submit pictures via Blackboard. The learning management software could automatically credit them after I gave their work a quick review. I could automate the solution videos and answer keys to go live after the due date, in which students would then reference these while conducting their reflections. There was no need for paper shuffling, and I could focus on in-class time on lending support to students who had signaled through their reflections that they were struggling. So in conclusion, 50 years ago, Robert White challenged us to grow as calculus instructors, and in those 50 years, we seem to have made little progress. There is now support for instructors, educators, and administrators to put into place classroom practices, not only in calculus, but in all levels that undervalue grades and instead attend to students' learning and their conceptual development. This framework satisfies the traditional administrative requirements of teachers to provide grades, all without sacrificing the integrity of the classroom. So it's with great hope that I hope that this year marks a transition. I hope that you all consider adopting this framework and sharing your results with me. Together, we can stand to gain greater student success in math education and, for that matter, all education. So at this time, I would like to say thank you all so much for attending my presentation. I'm going to open myself up to questions that anyone attending might have. My contact information is here in front of you. I encourage you to reach out to me on either LinkedIn or my brand new YouTube channel, in which I expect to be uploading much more information in regards to this subject and others related to it. So thank you so much for your time.
All right, thank you so much, Professor Shryock, for sharing that presentation. We do have some questions, but feel free, audience, to keep adding to the Q&A. And going through, the first one, to clarify, was feedback given on did they give feedback on the assignment that you highlighted?
So students were only required to fill out that checklist. What they did beyond that, a couple of them, actually a number of them, did go beyond that on a pretty regular basis. So they would write me notes that say, oh, I recognize that I had made this mistake. Here's what I was thinking. But the only thing that was required as a minimum was that they scored themselves and got an awareness as to what their performance grade would have been had it been graded on performance.
Okay, we had a few people ask if the recording will be available, so I just wanted to reiterate that yes, the recording will be available for review. Everyone who attended today will receive a link sometime in the next few days, so you can check that out again whenever you'd like. Some did ask for a copy of the PowerPoint slides. Professor Shryock, do you mind sharing those with us?
Nope, that's fine. Why don't we put that on the exact same website where the other documents were?
For sure, perfect. Okay, so then you will receive those as well with the recording.
If anybody is interested on the underlying stats and the data analysis and would like to reach out to me via this email address, I'd be happy to send you a copy of the thesis, which goes into much, much more detail that I didn't want to bore you all with this time.
Okay, another question. How are the point values on self-reflection found? I saw 1 out of 1 and 2 out of 2, but did not see clearly where they came from.
Oh, good question. So let's go ahead and jump back, excuse me, as I run us all through a big eye chart here. So on this rubric, what you can see off to the left-hand side is a score. Here we have 10 out of 10, 5 out of 5, 3 out of 3, etc. And this is for the Mastery Plus. This pretty much means they did everything perfectly. Students recognized that they not only had the right answer, but they got there in a good way. They communicated proper understanding. You can see that, actually, let's go back one more. This category off to the left is mirrored as we go further and further down. And in each one of these, it will say something like, for the next level down, it's 8.5 out of 10. So if students believe that they performed at the mastery level, then they would say, oh, I believe I get a score of 8.5 out of 10. Now, there are more levels here than you would normally grade incrementally between 1 and 0, for example. So if you had a 1-point problem and a student makes a typo on it, they have a choice to make. Do they think that they deserve a score of 1 out of 1, or do they believe they deserve a score of a half out of 1 or 0 out of 1? There's no option for 0.835, whatever their calculator would tell them. So they kind of have to do the exact same judgment call that a teacher would, which is this a big enough problem or error that they deserve being marked down, and then how far down would be reasonable. So the rubric provides a nice little template and a guidance for them, but as with all grading, there's a bit of a judgment call, and that kind of helps them to build their awareness. How big of a problem is this? Is this just that it's not as clear as it could be? Is it that it's actually unclear and undecipherable?
Awesome. Thank you for sharing. We had one question that was specifically about the absolute performance slide. Professor Hermiller asks, there are no y-axis scales shown here. Are they the same for all four graphs?
Let me see. Oh, I remember which one you're referring to. This one here, right here, right? No, these are not exactly to scale, other than to the relative proportions of the bar graphs. So the actual, this is simplified for PowerPoint presentation, but if you are interested in what the y-axes are or the specifics of the measurement scales, reach out to me via the email, and I'd be happy to share with you the supporting data for it in a more detailed graph.
Awesome. Somebody asked, she said, was wondering how you avoided the results being possibly disingenuous between when you're splitting from T1 and MT into 3 classes and T3 and Fin into 4.
Let's see, into 3 classes, and I might need a little bit more detail around that one. I'm very interested in that question, but I'm not exactly sure which part they're referring to.
Okay, well, Holly, if you're
Well,
still
I'd like to
here,
get back to that one, but if you
please
could.
put that any clarifying information into the Q&A and we will address that. Bindu asks, is the self-reflection done after every quiz and test, or was it on a different assignment before every quiz and test?
No, so the reflection happened at every single opportunity for where traditional grading would have occurred. So if there was weekly homework, that was written homework, that was given, reflections were asked for that, written quizzes were given, projects were given, tests were given. Every single time that a grade would have normally been attached to a written piece of work in a traditional classroom, this self-reflection replaced it, except for in the case of tests, in which case it was given in parallel. The students completed the self-reflection and then received a grade that I had already determined for them before they turned in their self-reflection worksheet.
Thank you so much for clarifying. I think you answered this already, but to reiterate, what do you think are some possible confounding variables between DFW rates and choice to have reflection conditions?
There's definitely a lot. I mean, this by no means. Okay, so without getting too much into the fuzziness around math education, there becomes a decision that has to be made, which is, do you conduct an experiment in a laboratory type environment in which you control a number of confounding variables, but then you lose the authenticity of doing an experiment in a real environment where students are not being necessarily controlled in all aspects, where you are allowing for a classroom environment instead of just an interaction between a researcher and an individual student, versus if you do something in the classroom. So a couple of confounding variables that I chose to accept. One, definitely me, right? I am one instructor who has sometimes a very unique style of teaching, so this would be a study that would definitely benefit from replication with other teachers, and then to get a community of data to support this. Other confounding variables, there was a slight difference between the national demographic populations that the MAA represented or referenced in their research versus the students who were in my class. I do attend or teach at a more commuter campus as opposed to a residential campus, so that can be a little bit of something that might be different between my experience and somebody else's. So lots of small little details, but I don't think any of those would impact to the point of making these results invalid. They just might need to be accommodated for by the teacher being aware of them.
All right, Holly's back, and she said for test 1 and midterm, the bar graph displays 3 classes, and then for four for test 3 and the final exam.
Okay, so sorry, now I understand. These bars here are not classes. These are just simply groupings of students so that you can see between a general high score and low score, where is it that students who are either opting in or not were generally falling in comparison. So I wouldn't look at this as trying to compare test 1 to final. Look at, within test 1, compare the red bars to the black bars. But there was only one class that was experimental, my class, and I compared it against 2 control groups. but those aren't represented in this slide. This is just simply helping you kind of batch students together to get an idea of where the trend was. Again, this is just for presentation mode, very much simplified, but if you're interested in the details supporting this graph, reach out via email and I'd be happy to send those your way.
Awesome. Thank you so much for clarifying that. Some people were asking about whether they could view your self-reflection grading rubric. I did put the link to that in the chat, and it will also be available alongside the recording and the slides once we get that out.
Mm-hmm. And I do want to stress again that that rubric, full credit for that rubric, I mean, it's just small adjustments, but the majority by far of that rubric's credit goes to Grays Lake North High School in Grays Lake, Illinois. Thank you guys very much. They've developed that thing for 5 years and continue to grow it as a dynamic document. So absolute props, Kevin.
Awesome. Professor Clardy said, I believe you said that you still used performance grades for about 70% of the course. Would you say that you would do more or less in the future?
I don't think, well, so it wasn't 70% of the course, it was 75% of their final grade was determined by performance scores. So would I do more or less? I thought this was a pretty good number. I actually didn't have control of it. It was a department standardization that we had chosen, but it actually worked out quite well because you could time-wise and effort-wise and student attention-wise, 90%, 80% of the students' time and attention was on learning. And very little did they have to kind of stress about the test. It was usually only the week before that a lot of them put time and effort and stress towards what the test score was going to be. Most of the time it was just on learning. So that worked out very much in the benefit of keeping their mind open and promoting the learning. But the confidence that the scores or the grade, the final grade that the students had when they left the class was reassured by the fact that they had gotten most of their grades from performance. So it's kind of the best of both worlds. Most of their attention was on learning, but most of the backing for why they should be deserving of a passing grade was based on performance.
All right, thank you. Someone said, I am still confused about how the course grade is calculated. If a student fails the midterm and final, but correctly self-reflects about their work, what would the grade be?
Okay, good question. So the test, midterm, test 1, midterm, test 3, and the final all come out to 75% of their grade. So if they absolutely 0%ed on test 1, midterm, test 3, and the final, but they got all their completion credit, they would get a 25% score for their passing grade, which would be an F. But if they, let's say, did none of the reflection and got 100% on test 1, midterm, test 3, and final, they receive 75% as a passing grade, which was a C. So most of the time, the general story worked out where almost every single student was doing the self-reflections with earnest, missing maybe a few due to just not managing their schedule well. So they were getting, we'll say 80% and above of that 25% that was attributed to self-reflection. And then we'll say the average was a C for across everybody on tests. That was putting them right about at the C range still. So it was working quite well as far as a weighted average is normally concerned.
Okay, I think you answered this, but how was self-reflection performed and did it add to the workload of the teacher?
It did a little bit, but as I kind of mentioned in the virtual experience, it got better as I became a little bit more aware of what liberties I could take with it. So the way that it would work again is that the student would complete a piece of homework in earnest. If they didn't complete the homework in earnest, let's say there were 10 questions, each was worth 1 point, and they only attempted 8 of them. Then they only got 8 out of 10 for their completion credit, but then they could reflect on it. And if they reflected and they reflected on every piece of work they did, they got 8 out of 10 again. So they could essentially match their completion credit with reflection credit, and that was how that grade was calculated. They did this in referencing the rubric. I'm sorry, I think I lost track of the last part of that question. Help me out with.
Let me find it again. Oh, did you use any online tools to help you with it?
Why it became easy. Okay, good. So in the beginning, there was a lot of paper that was fluctuating back and forth. Students would have to turn in an assignment. I would have to review it for completion. I would have to give it back to them. They would have to do a reflection. They would have to give that back to me. It became a lot of logistics. It was annoying. Did it take a lot of time? No, because I didn't have to write feedback. I didn't have to do much more than just simply highlight the errors that were pretty apparent to me, and to turn that back, the students were carrying a bulk of their own learning experience. So that part was actually equal. Come the virtual environment, it became significantly easier because I just simply would post a worksheet or assignment online for them to view, and then they could write their answers in their notebook. They didn't have to worry about printing. We were trying to promote some equity and make sure technology wasn't an issue. So they just simply write their answers, take a photo of it with their phone, upload it to Blackboard via an app, and the software would just simply recognize that, like, hey, they have submitted something, you can review it, and just give them full completion credit if they're deserving. That made the grading go by so quickly. It also didn't make them have to rely on me to feedback and return the assignment before they could reflect. I could make the answer keys and the walkthrough videos go live the day after it was due, and then they could just simply watch those while completing their reflections and turn those in for credit as well. So that worked out significantly easier, where now I could just simply look through and I could validate that this process was taking place and that the students were just kind of learning naturally as a result of it, as opposed to managing the logistics of papers back and forth. So I will never look back, and I will always use Blackboard or some kind of learning management software to now support the submission of the original work and the reflection credit. And once you make those solution keys and walkthroughs, there really isn't a lot of semester to semester work. And also, it didn't matter if students were cheating. In fact, I usually promote quote unquote cheating on homework and quizzes because that's just group work. That's finding elegant solutions. That's supporting each other's ideas. That's vetting a solution that their partner came up with and then putting that up online. So if they found the answers or got a tutor, it pulled all of that to a common playing field where it wasn't about did you get the answers? It's about, do you understand the answers, and can you reflect on how you presented them?
Thank you so much for that. Another question, if self-reflection is optional, why are students still being held responsible for the 25%? Or was it understood that opting out meant losing the 25%?
No, so the way that I conducted this experiment originally is different than I now run it. So when I did it originally, I didn't know if it would work. So I needed to give students the option to choose to opt into this if they wanted to. And so if they opted in, then they were essentially, they signed a small little informal piece of paper saying they recognized all the details of the arrangement, that they were going to only get graded on their completion and their reflection, and that would give them 25% of their grade. And then tests and everything would be the same as normal. If they chose not to opt in, then we just ran their interaction and my interaction as a traditional classroom. So they just got grades based on performance. So if a student said, I would like to be I would like to do the reflection option, what they were saying is that they understand that I will not grade them on performance. I will simply grade them on whether or not they get it done with earnest and whether or not they reflect. So they have a little bit extra paperwork to kind of do as a result. If they decide they don't want to do the paperwork and they want to take the risk of just grade me on whether I'm correct or not, then we ran it as a traditional classroom. And the results showed that students who chose to be graded on their performance at all points in the class did not grow as much as students who took advantage of the opportunity to focus mostly on learning.
Awesome. We had a couple of people ask if there are any studies that you referred to evaluate the success of the method.
There were I would say probably 30 pages worth in my thesis where I was backing a lot of this up with other research that others have supported. Number one that comes to my mind, Jo Boaler. Big fan of Jo Boaler. She has often promoted in a number of her books that grading is something that promotes math anxiety. It causes students to not focus on learning. It causes them to have very poor relationships with teachers. It causes stress within the household if they're a K through 12 student. So instead, again, she promotes explorative activities, reflection, homework that is based on journaling, etc. So big shout out to her, and she has done a bunch of work. There's also plenty on feedback in general, where it says that teachers who give grades and who, you know, either give grades or give grades and feedback, that the majority of students do not benefit from the feedback if there is a grade attached. They actually either put it in a folder or they throw it away, but the improvement does not happen unless you remove the grade from the page entirely. And then if you provide feedback, students are more interested in engaging with it because they don't see it so much as, well, I did it, it's over now, on to the next thing. They do it more as a growth exercise. So again, reach out to me. There are lots of things that I referenced in my piece, but I have to send over a PDF for you to review through. That's an important question for you. I think you'll really enjoy the reading.
Thank you so much for that. We are approaching 2 o'clock, so let's do just a couple more questions. And if anyone doesn't have their questions answered, feel free to reach out to Professor Shryock or to us at marketing@hawkslearning.com.
Flip over to those contact information again for everybody.
Perfect.
There we are. Great.
All right. Professor Wright asked, did you need any special permissions to do a study like this with the students?
Yeah, this was very, there's a lot of different people that I had to consult with this. I did have a committee that was guiding me the whole time. My immediate advisor was an associate professor of math education, and so she verified a large amount of my research that I was backing this on before I decided to conduct the experiment. I did have to coordinate it with the calculus coordinator. I had to coordinate it with the dean, with the chair of the department, and also with, I believe, the chair of undergraduate success, I believe is the title. So there was probably, 7 or 8 established professionals at the university that I had to consult with and convince that this was something worthy of investigating. And after the first semester went very well, the second semester I ran it was less of a risk, and it turned out to have almost identical results. So very positive backing.
Okay, a few questions about controls. Did you have an independent control group? It seems like your control was self-selecting students who chose not to participate, and the control group changed throughout with students dropping and switching to participate or not.
Okay, good question. There were 2 levels of comparison that happened. One was within my classroom. So within my classroom alone, students had the choice of opting in or opting out. And that's naturally going to cause the samples to vary, right? As we mentioned, the students who are more willing to do the extra work in exchange for more surety in their grade are going to opt in. Those who really won't be bothered are going to opt out. That's going to immediately cause the population to be a comparison rather than a control. So in order to get more assured results, I was also referencing the midterm and the test scores, which, if you'll recall, were graded by a committee that was independent of my class. And I was comparing to 2 other sections. So I compared those tests in both of the groups that I was of control of to 2 other control sections that were similarly being led by a TA, which I was at the time, with similar experience. And on both levels of comparison, those in the self-reflection option outperformed. So those who were given the option of self-reflection outperformed those who chose not to take advantage of the option, and those given the option outperformed those not given the option. So I ended up running what's called a 2-ways mixed factor ANOVA, I believe, in order to make sure that, yes, in fact, not only within my class, but within that choice, there was enough confidence to say it was statistically significant.
Thank you so much for clarifying that. Does a student use the rubric for every question on every assignment, or is it just for an assignment, like the whole thing?
Every single one, and I cannot stress enough that that is probably the best part of this framework. Having students really grow in their awareness as to what it was that I was looking for as a whole, as opposed to a particular assignment, help them broaden their awareness. So for example, one of the bullet points that's coming to mind was something along the lines of, I got the correct answer, but the way I presented it was not clear enough that anybody could follow my work. And that was a bullet point that that they could apply to homework, quizzes, tests. They could generalize this awareness to say, am I not only getting the correct answer, but am I presenting it clearly? Am I considering how other people might be viewing my work? And that allowed for a consistent message. It also allowed for students to feel empowered if they ever wanted to propose that they needed a different grade, right? There were a couple of conversations where students, in every semester, there's always, hey, I think I deserved a better grade than this one. Fine, absolutely. They had the syllabus since day one, and so they were told that if they at any point think they deserve of a better grade, they just need to bring up the assignment. They need to point to the bullet point on the rubric that they think better describes their work, and we will have a conversation around that. And that made students feel like they did not have to be passive in their education at all. So yeah, definitely. It was a holistic rubric. Highly recommend. Feel free to take a look at it on our website.
All right, we're going to take probably 2 more questions. There's still quite a few though, so I'm really sorry to everyone who might not get it answered live right now.
Send me an email. I would love to answer your question.
There were some questions revolving around how self-reflection grading happened virtually.
So the actual process was that students would pull up a worksheet that I had asked them to do on Blackboard. They could view it in their browser. They would answer it in their notebook, and then they would take a photo of it, and they would submit that photo up online. That would immediately trigger in Blackboard that, hey, the student has submitted some work. You can now review it. And I could quickly go through and I could just verify that the student had attempted the problem in earnest. And then the student would receive full credit for having completed the assignment. The next day, the solution key would get posted. Students would then have until the end of Monday. So assignments were due on Friday. They had until the end of Monday to complete their reflection, or end of Tuesday, I think. And Tuesday to complete their reflection. So they would, again, fill out a worksheet, or they would copy the worksheet in their notebook, or put the information the worksheet would have contained in their notebook, whatever was required for their circumstance. Take a photo of that, and then submit that up onto Blackboard. And then again, I would go through and I would just identify these places where students who have already looked at the answer key and they've already looked at the video are recognizing that, like, hey, this spot right here, I have incomplete understanding around. And so in the class period, I could reach out to them and say, hey, I recognize that, like, on question 5, you said that you had incomplete understanding. Do you believe that you understand it better now? Or do you believe it's a little bit still confusing? And they'd go, oh, it's definitely still confusing. And we could use that time together, or I could refer them to office hours where we could have time together to really solidify in that understanding. It really emphasized the dialogue between us as opposed to just you received a grade and we're on to the next assignment.
Thank you so much. For probably the last question today, how do you use work experience in industry with your students?
I am a big fan of catering to an audience, and that might just be the professional, engineer in me speaking, but I think that if over 90% of your class is not going towards a career in academia or in theory, that you should be presenting your message to where they will go. And since for me in Calculus 1, the vast majority were engineers, computer scientists, bioscientists, geologists, it's about pulling in that experience and really saying, okay, here we have a derivative. Is it important that you be able to calculate a derivative? Yes-ish. Should you be able to understand the mechanics? Yes. Should you be able to reproduce those mechanics? Yes. Do engineers, biologists, bioscientists calculate derivatives on a regular basis? No. But they do need to understand the ideas of change, the ideas of graphs, the ideas of functions, the ideas of how it is that behaviors can sometimes be different than values. And so you really get to say, like, hey, I've been in meetings where they talk about trends. And for that reason, you may want to pay attention here while we talk about limits, because that's really what trends are. And so if you want to be a productive member in this meeting that you will eventually be invited to as a professional, then perhaps you'll want to study this material here because it will give you an awareness that you don't already have.
Awesome. Well, we're out of time now. Thank you so much again, attendees, for coming today. And thank you so much for sharing your project with us, Professor Shryock. I didn't read these out as they were coming in, but during your presentation and afterwards, you also received a lot of thank yous and people commenting on how they found your methodology interesting and how they were hoping to try it out.
Well,
so if anyone has any other questions, please feel free to direct those to either Shryock at the email address that you can see on the slide, or to us at marketing@hawkslearning.com. As a reminder, we will be emailing you a link to view this webinar on demand, so look out for that sometime soon. Thank you so much once again. I hope everyone has a great rest of their day.
Thank you so much, everyone.
Bye.